Hey, good afternoon, guys. Coming to you this week about a discussion question from Module 5, replication of effects. We're describing how prediction, verification, and replication should occur in this study as it proceeds. First of all, in order to increase the confidence in as the cause effect in the student editing and revising, essay, the teacher used the flex strategy to increase the confidence in him, the motivation for him to use use that strategy when revising the essay. First of all, we need to resolve the issue of replication of effect, the issue of prediction, verification, and replication. This can be described with using AB withdrawal design. Also, the teacher came up with needs to come up with some type of token economy to increase the motivation for the students to use the fixed strategy. We're gonna go over AB withdrawal design first. After stable baseline conditioning, one will predict the pattern of the behavior from session 1, 2, and 3, which is 33% session 1, 0% session 2, and 0% session 3. Those are the three essays that he wrote, and that was the data coming from him writing using the flex strategy. Those three sessions, creates the stable baseline. So now, prediction. Stable baseline condition is 33%, 0%, 0%. The pattern of behavior is going to continue or remain the same if the intervention had no effect. One was not put in. So as the interventions come in, as we implement intervention, if it didn't have no effect, the pattern is going to be the same. If we use the intervention or reinforcement program has an effect, then a different pattern will show. The different data will show. Verification will change from baseline to intervention condition, result in change. So it will change from baseline to the intervention. The data will change the result. You can see the result. Then the verification occurs when we return to the baseline again and the condition again. Data will return to the previous day baseline. So you will see the data, being common, the same as the first baseline. And then moving to the, replication occurs when the second phase of or condition of the reinforcement is put into play. So we may see the similar response from the previous condition of the reinforcer when we're coming up with the replication. So you should see a change, in those different stages of the AB design, withdrawal design, from the prediction stage to the verification stage to the replication stage. So during the prediction stage, we had to come up with a stable baseline, which was 33%, 0%, and 0%. Those were from the three, essays that he wrote using the flex strategy. Then we went over to the predicting stable baseline condition. It's going to change. It won't change if the intervention that we put in is not effective. It won't change. The data won't change. It'll be the same if we didn't come up with an intervention at all. But if we came up with a great intervention, which was the reinforcement program that he came up with, you will see a different pattern in the data. You will see a different pattern in the data that you plot. Also, the verification chain, when changed from the baseline to intervention condition, it will result in an interchange. Verification again will occur when we return to the baseline condition again. data will return to the previous baseline. So you will see this basically the same data from the previous baseline. Replication will occur when the second phase of the condition of the reinforcer is put into play. So when the second reinforcer is put in place, that's when you will see the replication from the previous condition. We may see a similar response or a different response from the previous condition again. So this is where we have prediction, verification, and replication in this study. So your data points will change if you come up with an effective reinforcer, to change that baseline. It will change. All right, thank you.